Hello students, in this video we are going to discuss 1.10, 1.11 and 1.1. An electric dipole with a dipole moment 4 into 10 power minus 9 coulomb meter is aligned at 30 degrees with the direction of uniform electric field of magnitude 5 into 10 power 4 Newton per coulomb. Calculate the magnitude of the torque acting on the dipole. The situation will be like this. It is uniform electric field. And there is an electric dipole. The force acting on the positive charge will be towards right according to this diagram. The same direction of electric field. On minus Q will be towards left. We know the force acting on the positive charge is in the same direction of electric field, and a negative charge in the opposite direction of electric field. And dipole moment is making an angle 30 degrees with the direction of electric field. So definitely it will experience a torque. So what is the value of torque? Here he asked the magnitude of the torque. So given dipole moment is equal to 4 into 10 power minus 9 coulomb meter, and theta angle between electric field and dipole moment is 30 degrees, and the magnitude of electric field 5 into 10 power 4 Newton per coulomb. This is the data given. We need to calculate torque. Tau is equal to Pe sin theta. P is 4 into 10 power minus 9. E value 5 into 10 power 4 sine of 30 degrees. So we will get here that is equal to 20 into 10 power minus 5 into half. So 10 into 10 power minus 5, that is also can be written as 1 into 10 power minus 4 Newton meter. So this is the torque acting on the electric dipole which is placed in uniform electric field. And coming to 1.11. A polythene piece rubbed with wool is found to have a negative charge of 3 into 10 power minus 7 coulomb. In the data already given, there is a polythene and wool, both are rubbed against each other. This polythene acquires the charge of minus 3 into 10 power minus 7 coulomb. That means wool will have the charge plus 3 into 10 power minus 7 coulomb. That means the electrons are transferred from wool to polythene. Coming to the sub questions. Estimate the number of electrons transferred from which to which? From wool to polythene. The answer is from wool to polythene. And number of electrons. While coming to number of electrons, we can use this formula Q is equal to Ne, the quantization of the charge. N is equal to Q by E. That is equal to Q, we are taking the positive. Charge on the polythene is minus, charge on the wool is positive, but here we are taking just magnitude alone. Q is 3 into 10 power minus 7 divided by charge of the electron 1.6 into 10 power minus 19. After simplification, we will get 1.875 into 10 power 12. That means 1.875 into 10 power 12 electrons have transferred from wool to polythene. This is the answer for A. Coming to B, is there a transfer of mass from wool to polythene? Means definitely the answer is yes. The mass is transferred from wool to polythene because of transfer of electrons. But this value is very smaller, negligible, but some mass is transferred. How much amount of mass is transferred? So the mass m is equal to number of electrons into mass of each electron. Number of electrons are 1.875 into 10 power 12. Mass of each electron is 9.1 into 10 power minus 31 kilogram. So that is equal to nearly we will get 1.71 into 10 power minus 18 kilogram. Right. This amount of mass will be transferred from wool to polythene. But this negligible value. Coming to 1.12. Two insulated charged copper spheres A and B has their centers separated by a distance of 50 centimeter. What is the mutual force of electrostatic repulsion if the charge on each is 6.5 into 10 power minus 7 coulomb? The radii of A and B are negligible compared to the distance of separation. That means the radii of A and B negligible compared to the distance of separation means we can take the two spheres are point sized. So we can imagine there are two spheres A and B. Their radii is negligible with compared to distance between them. So the gap between them R is equal to 50 centimeter. Assume that the charge on A is Q suffix 1 or Q suffix A is equal to 6.5 into 10 power minus 7 coulomb, and charge on B Q2 if you are assuming 6.5 into 10 power minus 7. Both are same. We can write Q1 is equal to Q2, no issue. Now what we need to find out? What is the mutual force of electrostatic repulsion? Both are having same amount of charge, so force of repulsion will be there. So what is the force of repulsion? F is equal to, we have the formula K Q1 Q2 divided by R square. Here Q1 Q2 both are same, so K Q square divided by R square. That is equal to K value is 9 into 10 power 9, Q value 6.5 into 10 power minus 7 whole square divided by R value. R is given as 50 centimeter, the same we are writing 50 into 10 power minus 2 meter also in terms of SI, divided by 50 into 10 power minus 2 whole square. After simplification, this value we will get 1.52 into 10 power minus 5 Newton. This is the force of repulsion. Coming to B. What is the force of repulsion if each sphere is charged double the above amount and the distance between them is half? That means we can imagine the new charges Q1 dash is equal to 2 times of Q1 and Q2 dash is equal to 2Q2 and R dash is equal to R by 2. Now the new force of repulsion F is equal to F dash is equal to K times of Q1 dash into Q2 dash divided by R1 dash square. That is equal to K times of Q1 dash is 2Q1, Q2 dash is 2Q2 divided by R1 is nothing but R by 2. R1 square is R dash square is equal to R by 2 whole square. So that is equal to, we can write 4 times and it will becomes 4. So 16 times of K Q1 Q2 divided by R square. That is also is equal to 16 times of initial force. That is equal to 16 times of initial force. We got 1.52 into 10 power minus 5. So after simplification, we'll get 2.432 into 10 power minus 3 Newton. So F dash, there is new force of repulsion when the two charges are doubled and distance is reduced to half, then new force became 16 times to the initial force. So these are the solutions of the above questions. Thank you.